Hello, friend. Welcome to Marine Engineering Hub. This is your narrator Ravi Gupta. Today, we're going to talk about air cooler. In today's video, we'll know that why air cooler is fitted in a turbocharger system. What are the disadvantages of having an air cooler? And through a series of diagrams, we'll try to understand the construction of an air cooler and what are the components fitted and why it are fitted and how it is cooled and how it is cooling the air. And then we'll talk about the different type of attachment which are fitted and why it is fitted and why it is necessary. So this is the fifth part of our turbocharger series. Before that, I have made video regarding pulse type and pressure type turbocharging, type of scavenging, and supercharging and scavenging difference and what is scavenging. I will keep my all video in the description box. You can watch it from there, or you can go to the playlist and you can see there the turbocharger series. In that you can find all the video. So let's begin the today video. So first question is that where is the air cooler is installed. So this is a simple diagram. In this diagram, as you can see, the air cooler is here. So basically the exhaust which is coming out from the cylinder is driving the turbine, and this turbine while driving it is compressing the air through compressor, and that compressed air is coming to this air cooler and it is been cooled, and then it is been provided to the scavenge manifold. So if anybody asks you that where the air cooler is fitted, air cooler is fitted after the air compressor and before the scavenge manifold. Okay, this is the placement of an air cooler. So let's see. Air cooler is fitted. Why? It's fitted on a turbocharger system to cool the air. So the first primary purpose of an air cooler is to cool the air which is coming from the compressor. Means the air from the compressor inlet is being cooled by the charged air cooler. How? What is happening? The air cooler is cooling the air to around 40 to 45 degrees Celsius because it has been adiabatically compressed in a turbocharger where temperature increases to 60 70 degrees Celsius with reduction in density. Atmospheric air contain water vapor, and when the air is cooled, the vapor can condense. The temperature at which condensation takes place is called dew point. So let me tell you first, this is the construction of an air cooler. So as you can see, this is the air cooler, and now we're gonna see the expanded view of this air cooler. The cooling water is coming from here. So basically first thing I want to tell you is that the air cooler design is in this type, is a fin type. This fin is provided and the air is passed through this fin. Means the air is in outside and water is flowing to the inside of tube. As you can see, this will give us the idea. The air is passing from here and water is flowing through inside of this tube. Okay, now this will clear doubt. The air is coming from here. This is the hot air which is coming from the compressed compressor, and its temperature is around 200 degrees Celsius. Means around 140 to 150 degrees Celsius is the normal temperature. Is coming out, and the air cooler is provided with a lot of fins. Is provided. This fins is been provided so that it can dissipate the heat in a shorter amount period of time. Large amount of heat can be removed with the help of the fins. Why fins are provided? Fins are provided so that we are increasing the overall surface area of contact of a air that is flowing to the air cooler. By the number of fins, we are increasing the surface area. As the surface area is increased, the contact of the with the cooler is increased and the air is cooled in a very short amount period of time. So now the cooling water is coming from here, is passing inside this tube and going here and then coming outside like this. Okay, one more time I will tell you. The cooling air, the cooling water is coming from here, is passing through inside of this tube. How? This will give us a clear idea. This is a tube. The cooling water is flowing from here and the air is passing from outside like this. The air is passing from this outside. Okay, and as the air is passing from here and water is flowing from here, one more thing you need to care: the air is passing perpendicular to the flow, means the flow is not in a same direction, is in the perpendicular direction. Okay, and if anybody asks you why the fins are provided, you know the answer, I hope, right now. And now the hot air is coming from here, the cooling air is going from here, and therefore the temperature after passing through the air cooler is 40 to 50 degree Celsius. Now this is the water catcher vents. Why it is provided? Because what is happening when the hot air is coming, hot air contain some amount of water vapor. When it is cool, the water vapor condense, and to prevent this condensed amount of water to go to the scavenge manifold, this water mist catcher is provided, which will catch the water and it will drain it to the scavenge drain tank, or you can say to the oily bilge tank or bilge tank. It depends where you want to drain it out. Normally, in most of the cases, it is drained to the bilge holding tank. Okay. Now, some may ask you the type of material which I use. So I will give you a quick synopsis. The end plate is of naval brass. Okay. The aluminum brass tubes with solder on copper fins is used so that to increase the surface area. The overall box is the cast iron water box. Okay, so the naval brass is the fixed end and the moving end. The aluminum brass tubes are the tubes with the copper fins, and water is moving from here, it is going like this and coming out from here, and water is flowing from, sorry, the hot air is flowing from here. Now let's see what I have written here. Okay. Atmospheric air contain water vapor, and when the air is cool, the vapor can condense. Okay, why the vapor is condensing? Because as the temperature of the air, as you know, the temperature of air is being reduced from 200 to 45, the water vapor inside the air is getting condensed, and the temperature at which it is happened is called dew point. Now if somebody asks, okay, I will not fit this water mist catcher, I will not fit this water mist catcher, what will happen? Let the water go to the engine, what will happen? So your answer should be, the water droplet entering the cylinder with the scavenged air will remove the oil film. Very important. What is happening? The water which is going, if the water mist catcher is not here, the water which is going to the engine will remove the oil film which is present in between the liner face. And what will happen? Causing excessive frictional and corrosive wear, leading to increased cylinder liner and piston ring wear. So, if anybody says you, okay, I will not fix the water mist catcher, so what will happen? Your question should be, sorry, your answer should be that, sir, if you don't fit the water mist catcher, water will go to the combustion area and it will remove the oil surface in the cylinder liner, and therefore the frictional wear between the piston and the liner will increase very much, and it will increase the corrosive wear of the liner very much will happen, and excessive heat will generate. It may also cause stucking up of the piston. Now second problem, let's see. Not only one, two problem is there, very important, why we are fitting that water mist catcher. Water contamination also causes thermal shock when contact with hot liner and piston. Therefore, air is only cooled to a temperature above dew point where condensation will not take place. Okay. Water contamination also causes thermal shock when contact with hot liner and piston, and therefore the air is only cooled to a temperature above dew point where condensation will not take place. It depends. If we are not fitting the water mist catcher, then we will not cool the air to that much amount, and if we are fitting, we will cool it to that much amount. Normally we try to, our main aim is to maintain a temperature of 40 to 50 degrees Celsius. If we maintain a temperature of 40 to 50 degrees Celsius, it has been seen that there will be no thermal shock will happen, because if the air is cooled too much below temperature, means 25 or 20 degrees Celsius, and now during a combustion process it will increase to 300 degree or 400 degree temperature. The temperature gradient is very much high, which will cause the thermal shock. If the temperature of the cooling air coming from here is around 40 to 50 degrees Celsius, and then the temperature gradient will be lower, and hence the thermal shock will be less. Okay, now the air cooler construction we are going to see, I have already explained you, I will just read it out. The air cooler consists of a number of fins through which air passes. Okay, it consists of a number of fins through which the air passes. Cooler must be sized to take account of the maximum engine load, maximum ambient temperature, and maximum seawater temperature likely to be encountered. So if anybody asks you that what are the things we should take into the consideration while choosing a cooler, so you should say this thing, sir, we will take into the account the maximum load of the engine, what is the maximum ambient temperature we want, okay, what it will be the maximum sea temperature, means where it gonna operate, and these are the condition for choosing a air cooler. If anybody asks you what are the criteria to choose a air cooler, these are the criteria we can say for choosing a air cooler. It is important that a charged air cooler are kept clean on both air and water side to ensure optimum performance. So it is very important that the maintenance and cleaning it to be carried out at regular interval period of time. Okay. Now one more thing I want to tell you, that this fins, as I've told you, the fins is increasing the surface area, and therefore it is providing maximum heat to be drawn out from the air in a shorter period amount of time. It is also it is also behaving a like a baffle plate arrangement. If you know that in heat exchanger, baffle plate are provided so that to increase the time of contact, to increase the time of contact in a shorter period of time, means we are basically what we are doing, we are reducing the airflow as it passed through a fin, and as it passed through the fin, it airflow reduces because of resistance of the this fins, and hence the surface area as it is increased, it will cool in a shorter period of time. Very important to understand. One more time, I will tell you what is happening. Suppose the air is coming from here of 5 meter per second. Okay. Now the fins are provided like this. So the fins is increasing the surface area. So it can remove the heat in a larger amount of heat in a shorter period of time. Now, apart from that, it is also acting a resistance to the air. So as the air will pass through the fins, it will reduce its velocity to say 2 meter per second. So as the speed is reduced, the contact time period will increase, and hence increase in the efficiency of the heat to be drawn out from the system and the system air to be cooled. Okay. Now this is the arrangement which you can see air cooler look like. This will be the inlet and this will be the outlet, and after that you can see this is like that. Okay. So I hope you understand how a air cooler is working. Now let's see the water separator. It consists of a number of vertical polypropylene blade set at an angle to an airflow. When the airflow hit the blade, it changes the direction, but water droplet with higher density and higher inertia cannot change direction, fall down, and water remove through condensate trap. Very important. So basically what is happening, as you can see, this is a water catcher, is basically consisting of a type of blade which are placed in an angle. You just see my hand. Basically what is happening, this water mist catcher consists of a blade which are placed in like this direction, and when the air is coming, it is being hitting it up. The water being a heavier will not able to change its direction, and it will fall down, but the air being lighter will move away. Okay. So I hope you will understand. Now please do subscribe and please do share my video with your groups, and it's a request that if you have anything, please comment below. I will try to reply, and please do share. Have a good day, friend. Bye bye.